Hello, folks, and welcome to Rational Science. Why are we rational? Well, we're a little different than all the others who are irrational. And we can see the differences here. We always put them side by side so we can compare what they do with what we do. Okay? There's a scientific method that these people follow. It consists of observation. They do descriptions. They do predictions, and then they repeat the process over and over again. And I call it the mathematical method because all they come up with are descriptions, mathematical descriptions. Math can only describe. It has no power, no authority to explain anything. In fact, all the explanations are irrational, coming from mathematical physicists, and they just brush it aside saying, well, first, that's philosophy. That's handled on the other side of campus. And then they also say, well, that is how Mother Nature or Father Universe run their universe, run the universe. But what happens? Give me a second here. Oh, something happened there. That's the way they run the universe. And your logic does not coincide with theirs. But I'm concerned about Father Nature's logic. I'm concerned about your logic. Your logic is the one I'm questioning, not Father Universe's. And then there's the issue of whether you represent Father Universe, Mother Nature. Does your logic match theirs? Would they say the same thing about your logic? Okay, so this is the issue. So what do we do that's different? Well, this is our scientific method. That's the one we propose. And it's a way of explaining something to someone else objectively. Okay? So we have these three steps. And primarily the first two, we have the objects, definitions, and the initial scene. That's where we start. We have to name the objects in physics. You can't do physics without an object. And then we have to explain the mechanism objectively. Okay, so yeah, we end up with a different universe than the mathematicians have for the last 400 years. They worked on it and they came up with all kinds of nonsense: black holes, dark matter, Big Bang creationism, particle can be at two places at once, all sorts of nonsense. And they say, well, we know it's irrational, we don't understand it either, but that's how the universe runs. No, that's how the universe runs if you explain it with particles. When you try to explain all phenomena out there, invisible phenomena, mediating it with invisible, discrete particles, then you have a problem. Then you end up with irrational conclusions. And what do we propose instead? Well, we propose this. We propose an interconnected universe. All atoms in the universe are physically interconnected. They're all bound to each other. And then we have the main system at the bottom. We have the atoms doing their quantum jump. And when they do so, they torque what we call the electromagnetic rope. And that torsion is what we call light. Okay? With this model, we explain gravity as well. We explain magnetism, electricity, the whole works. And you can look it up in the description. You will find a free book, downloadable book, PDF, illustrated book, so that you can just look at the pretty pictures and get an idea of what the rope model of light and gravity are all about. And here's essentially the synthesis, okay, and here it is. Essentially everybody else does discrete particles, and we do interconnected atoms. We don't interconnect them with concepts such as energy, mass, and time, and that sort of thing. No, we interconnect them with physical entities. Okay? Okay. Turns out that the mathematicians, mathematical physicists, so-called physicists, we call them mathematicians. Mathematicians is a better word. And they've branched out, like I explained the other day, into extinction. And a very closely related subject to extinction is this issue of whether we are alone in the universe. Are we the only life form that has ever arisen in the entire universe with so many planets, stars, galaxies out there? Could we be the only life out there? It would seem like the odds are against that. You would think that there is some other civilization out there, and then you got the issue of whether it's just life, something that, as we say, moves against gravity, or if it's a little more, it's intelligent like humans are here, that we can reason. Or are we just looking for ants out there? Okay, so that's the issue. But the question pops up as to whether the fact that we're alone, or that assumption, or the thinking of that, has anything to do with science. Does it have to do anything with science? And so here's the question. Okay. Is whether we are alone in the universe a scientific issue? Should we discuss this in science at all? Okay. Well, you can make an assumption, say we are the only planet with life. That's a good an assumption if you're going to use it for something, if you're going to explain something with that. Okay. But let's turn that around. Let's say you want to theorize that we are the only civilization in the universe, for example, or that there are either very few or many planets with life, okay, or that we are alone. Maybe you want to theorize we're alone because we haven't heard from anyone else. No one has visited us. No one has sent messages to us. Are those topics worthy of science? Do they belong in science? My answer to that is no. They do not have anything to do with science. Why? Because what those so-called theories are to demonstrate or explain, if that makes any sense, to explain existence. It's like saying you're going to explain the existence of God, okay? And you say, okay, how do you explain the existence of God when existence of God is an assumption? And these people might say, well, the atheist might say, well, God hasn't contacted me. I've never seen him, so he doesn't exist because of that. And the theist might say, well, I hear voices every night before I go to sleep, and I pray, and in the morning I get all the benefits of my prayer, of my faith. And again, what both are doing is, one is trying to prove, the other one's trying to unprove or disprove the existence of God. And, you don't prove or existence. Existence is something you assume. You make an assumption about something which you think might exist and then use it to explain something. And this is more or less the same thing. When you go in there and say, let us assume there's another civilization, another world with people out there, that's an assumption. You can use that for whatever. Okay, you can, for example, you can explain why you found an ET here on Earth, or some thing that they left behind. Okay, so you can explain and say, well, let us assume that there's another civilization. You can use it in that sense, but you cannot theorize about the existence of another world, because you don't theorize about existence. So that's an improper context for science. Okay. The other thing is that, if you actively search for life out there and say that you're doing scientific work, no, that's a no-no. That's why it's in black. No, that obviously is not science. Going out there and saying, I'm going to put a device to listen in, or I'm going to look for some gadget that the Martians left behind, maybe in the pyramids somewhere, that's not science. Okay? That's stamp collecting at best, or at worst. Okay? So, no, let's make sure we understand that. Now, one of the fellows who got involved with this search for extraterrestrial intelligence, otherwise known as SETI, that's the organization. His name is Paul Davies, and here's a quick summary of his bio. Okay, this is the fellow. Okay, And he's a mathematician, obviously, right? He proposes QM and GR. That's why he's a mathematician. He's going to explain everything with magic, voodoo magic, black magic, okay? And then he's going to say, well, yeah, we don't understand it either, but we've proven it. And here's the prediction, and here's the equation. That's the way they work with that. And your logic doesn't match Father Universe's. Okay, fine. He's got a PhD in mathematics, right? University College in London. And he did some postdoc research with Fred Hoyle, for those of you who know him, steady state universe, right? At Cambridge. And he works specifically on quantum field theory in curved space-time. My God, curved time? How do you curve time? I mean, you bend it, you warp it. It shows that, where he's coming from. This guy's not a scientist. He's not even a philosopher. I don't know what this is. This is nonsense. This is just people playing around with equations and saying they're going to warp time. That's their physical interpretation. When you question them, they backtrack and they say, well, we don't understand it either. We can't warp time. But then you ask them, why doesn't the Earth fly out of the solar system? Well, because we have this depression, and it's warp time, and that serves as a wall and prevents the Earth from flying out. That's the physical interpretation. It's the rolling ball, the little bead going around the bowling ball scenario, that weighs down the canvas. Okay, what are his main contributions to mathematics? These are three things. They're in the Wikipedia. It says, an observer accelerating through empty space will be subject to a bath of induced thermal radiation. And these guys get prizes for them. They get PhDs for this kind of stuff. And they get money. They get paid for this. Apparently he explained something about the fluctuations in the the cosmic background radiation, whatever that is, okay? The first to suggest that black holes evaporating via the Hawking effect, okay? Talked about that sometime in the past. Lose mass as a result of a flux of negative energy streaming. We have this concept, this abstract concept called energy, and it's streaming, it flows into the hole from the surrounding space. So space in mathematics is made out of energy, particles that combine to form nothing, and then they separate to form positive and negative particles that come in momentarily into the world to make the equations come out right, then they immediately recombine, go back. So this is what this guy worked on. Great. These guys get money for this, okay? That's important. You're paying for these guys most of the time, through government funds or grants or whatever. He teaches this nonsense at Arizona State University. He's also taught at other colleges. But the subject of today is that one. He's the chairman of the Post-Detection Science and Technology Task Group. I don't know about science again. If he's going to be searching for intelligence out there, he should really search for intelligence inside his own head, But if he's going to search for intelligence out there, that's not science. Okay, so he'd like to think it's science, but it's not. Science is about explaining something, not about searching for extraterrestrial aliens. That's von Däniken kind of stuff. Looking to see if they find a ray gun that they left in one of the pharaoh's tombs or something. That's nonsense. Got nothing to do with science. Now, this fellow, you wouldn't think much of him. In fact, I read about him for the first time in his book About Time. Okay, and shows you he's a mathematical physicist. He's a mathematician. Why? Because that whole book, not once does he define the word time. The book says about time, okay? And he talks about time all the time in the book throughout. He talks about Greek time. He talks about Newtonian time, Galilean time. He talks about relativistic or Einsteinian time. Not once, even in the glossary, does he define the word time. He just rants on about time. like if you knew what he was talking about. And he follows in the footsteps of Stephen Hawking, who wrote A Brief History of Time. Nowhere in that book do you find a definition of the word time, especially not in the glossary. Okay? So all these people, they talk about stuff they never defined. And that's typical of mathematical physics. Okay, so, but, you wouldn't pay attention to this fellow if he had no authority. And it's important in mathematical physics to get authority. That's the mathematical method. The mathematical method requires that you have authority. No authority, no one listens to you. Okay? More or less like me. Okay? You got to have authority. You got to have some prizes. Okay? Did this guy win any prizes? Oh man, he's been in a lot of beauty contests. And that's why, I considered him a caricature of science, caricature of physics. That's what he is. That's what all these people who go, and give talks based on their authority, based on the fact that they said, oh, I studied mathematical physics. So what? You know nothing about physics. You can't give me a single explanation how a magnet attracts another, why the pen falls to the floor. You can't give me a single rational explanation. What do you tell me? You say a particle can be at two places at once, and that time is warped. And then they say, yeah, we don't understand it either. Yeah, no kidding. So yeah, this fellow won a lot of beauty contests, and you can see there he's got a lot of Olympic gold medals, jumped over the line, etc. So yeah, he's full of medals. But see, he doesn't have as many medals as a guy like Stephen Hawking. Okay, he died a couple years ago. Stephen Hawking, the guy in a wheelchair. Okay, now Hawking, outranks him because he at least got a medal, the Wolf Medal. Okay, and I don't know about Wolf Medal because yeah, he did a lot of howling about what he found and what he discovered, etc., especially about black holes. He's the guy who made them famous together with Roger Penrose. Okay, I think these people should change their name and should call it the Rooster Foundation. I mean, if they're going to crow, I would put a rooster. That's me. I don't know. I guess Wolf would also satisfy that. Okay. But yeah, these guys just crow a lot about stuff that they never explained, okay? And they get all these prizes, and that's how they get authority. Once they have authority, hey man, you got a medal for knowledge, for intelligence. Now you can, put your thumb on any ant down there that tries to challenge you. That's what it's all about. It's a good old boys club, okay? But Davies, he doesn't have as many medals as Hawking, and he's missing the most important one, which is the CMB. I mean, and again, it's very important to consider all these things because they work on the basis of authority. That's what it's all about. Authority, authority, authority. They can't explain anything, but they shove it down your throat through authority, saying, hey, I got a degree from Cambridge. And you tell them, well, I've only got a high school degree, but I think what you're saying is irrational. Yeah, but I outrank you. And this is what gives them rank. But see, neither of these two guys, like, Lawrence of Arabia, I mean, he did something for the British Empire. He went out there to the Middle East, killed a bunch of people, so he expanded the empire. He never got a medal, so I can't imagine, Paul Davies getting a medal. But he got one from the Templeton Foundation, and that's worth $1 million at least. So, you may laugh at these guys, but they're laughing all the way to the bank. Okay, they do make a lot of money, selling all this nonsense. And, Templeton Foundation, what does it do? It tries to merge science with religion. They're saying, there's a fine line between them. There's no difference. It's not a cut and dry difference like we put it in rational science. You're either rational or you're irrational. If you're irrational or supernatural, you're doing religion. And if you believe, especially if you talk about opinions, if you're going to prove, if you're going to present evidence, if you're going to talk about knowledge, then you're talking about religion. In science, we don't do that. In science, we explain objectively so that you understand what you believe, whether you agree or not, is irrelevant to science. You can do that at home in your own time. Science is only about explaining. These people don't explain. All they do is try to convince you. That's why they're religious fanatics. Okay, and that's what mathematical physics has become. And mathematical physics to these people is a synonym of science and a scientific method. Okay, this fellow wrote several books, and here's a list of them. Again, maybe the last 10 books he wrote. He's written more than this. And again, you can see the About Time there, number 2. And the ones I'm concerned about today Are We Alone? And another one in 2010, The Eerie Silence. Why? Because he talks about whether there's life out there in the universe. He analyzes that, okay? And so what does he say? Well, here's a very quick synthesis of some of the issues, maybe the most important issues he touches upon in his book, okay? And here it is. Fellow says the following. He says, one of the issues, right? If we can make life in a lab, it would not show that life is easy to make by Mother Nature out there. These are my words, but this is what he meant, okay? So, the fact that we can do an experiment like they did in the 1950s, Urey and Miller, where they put some methane and other carbon compounds, I believe, and they give it a shot of electricity and they created amino acids. And they said, well, there's a step there, and it's a good experiment because if you can produce amino acids, which is the foundation of, or one of the stepping stones, one of the missing links of life, well, you got a good chance of giving an explanation because it's an important point, okay, to be able to do that. So in that sense, it's okay. But even if some bug would have crawled out of the flask, he's saying, well, does that really tell us anything about whether Mother Nature did it the same way or whether there is life out there somewhere else? Maybe this was a unique experience here on Earth in the entire universe. Okay, so we still don't know anything because we only have one data point, and that's Earth. Okay, he said, he asked, could life have restarted many times on Earth? And this is an interesting point because, conceivably, right? As far as we know, we trace life here on Earth, at least the crawling life, the one in the seas and upwards, to the Cambrian, Precambrian. You're talking about 600 million years ago. And the question is, if the Earth has been around for a little more, like say 4 billion or 5 billion years, well then maybe life started and ended many times throughout that period of time. Could have happened, right? And under the rope model, well, we have an argument that even favors that to some degree. So let's put the argument. The argument is that the Earth was not made by the flowing gases that made the sun, but it used to be a star. And it lost its outer shells, and it became a planet. And that's why our planet, the Earth, is both roundish. You can only produce that amount of roundness by being a star, and it also differentiated. So we like the other theory better. And again, the theory that the Earth used to be a star and not that it was condensed through the nebular hypothesis version that today is prevalent in mathematical physics. Okay, so we're saying that the Earth used to be a star. What does that mean? Well, let's assume that the 5 billion year old sun is true. That's the age given to our sun. If the sun is only 5 billion years old, that swirling mass of gases that condense to form the sun, let's concede that, okay? Then what we're saying is, yeah, maybe the sun condensed that way, but not the rocky planets. The rocky planets used to be stars as well. They condensed. They turned into these black dwarfs, as they're known, and it was captured by the sun and the rolling mass of gas, and created the solar system. So the Earth was there before the sun condensed into this little star that we have, and it gives us heat and light. Okay, that's our version. But if that's the case, the Earth was only captured about 4 or 5 billion years ago. And we're again assuming that these are the numbers, these are correct numbers. So if we've been around for 4 or 5 billion years ago, could life have started over and over and over again? Well, I think that depends a lot on the sun also, how old, how long, or what the process of the sun was for it to condense, begin to radiate enough heat and light that would allow for light to come on Earth. And I think that would have been a long process. So my guess, at least my guess, my assumption is that the one that I usually follow is that no, we won't find nowhere on Earth that there was a previous civilization, and that left something out there. Maybe they went to the moon. Maybe they went to Mars. Maybe we go to the moon, we find, some artifact that they left. I don't think that's going to happen. I think life started only once on Earth, and it may have started maybe, again, like 600 million years ago. And before that, the sun was in the process of condensing and creating the right conditions for Earth to have life. Okay? So that's my take on that. So I don't think there was a previous civilization here on Earth. Okay? Next point is that he says there could be other civilizations that do some astro engineering, some advanced alien technology, and they would maybe have like a radio beacon out there, like a lighthouse, scouting for life around their region or around the galaxy, right? And all we have to do is wave our hands and they'll see us, maybe, that sort of thing. We got to make some noise so that they can pick it up. And this comes pretty much close to another subject, which is the Kardashev Scale, which gives us an idea how we can detect them. Okay, and it goes more or less like this: you have 3 levels of civilizations, and it was created by this fellow Russian guy Kardashev. And he said, not Kardashian, by the way. And he says it depends on how much energy they use. You can, or how much energy they were able to conquer, to master. Okay, and here you have 10 to the 16 watts, and that would be at the planetary level. When you get to 10 to the 26 watts, well, you're talking about the stellar level. That means we conquered the entire solar system, and we are able to mine all the energy in our solar system. When you get to 10 to the 36 watts, well, now you're talking about the galactic level, okay? You're saying, okay, now we've conquered the entire galaxy. We've got our ships flying back and forth from one star to another. I suppose Star Trek-like, okay? And what this gives us an idea, or at least all these people, right? Especially the people at SETI, to which Paul Davies belongs, okay? Is that how we can detect another civilization. All we got to look for is stuff at the maybe stellar level, or hopefully at the galactic level, that detects something. Say, oh, here's a civilization that has conquered the galaxy, and say they've already are able to mine all the energy of the galaxy, and they do stuff that we cannot even imagine. And so we would be able to see something like that and say, oh, Jesus, this is not natural. This is artificial. Someone has doctored all this stuff, and now we can see it and say there is another civilization out there. So that's one of the ways they propose detecting another civilization. But then there's the issue that he brings up, Fermi's paradox. How come no one has contacted us? And yeah, you have people like von Däniken out there that say, yeah, they have been here and they left, and otherwise we wouldn't have the pyramids or who knows what, these ancient civilizations that had all this knowledge and technology, and we lost it over time, and now all we can do is just dig into the ruins and see if we can find the ray gun or the bullet or whatever they left behind, Have they been here? I say flatly, no, they've never been here. So those people who search for, ETs here on Earth, oh man, poor people. Uh, he talks about colonizing Mars. Okay, and again, we become the Martians, and that way, in a way, it's like saying, yeah, see, when the Martians wake up one day, they say, hey, there are Earthlings. Yeah, no kidding. We colonized you guys, that sort of thing. And there are people who have talked a lot and do things about this issue. First one was this fellow, von Braun, okay, Wernher von Braun, an SS officer who was recruited by the Americans and developed the rocketry for the military. And Wernher von Braun, I think he had a book in 1950s, early 1950s, and he suggested, he came up with a plan to colonize Mars, to go to Mars, and he already had developed that. He was developing rockets. He said, hey, we can take a rocket and take it not only to the moon, we can take it to Mars. Okay, and he knew that Mars, we could put a colony there, an artificial colony, so he was already with that. And today we have people like Elon Musk. He's working on that project heavily, try to get humans to Mars. And my only question is, for what? Why are we sending humans to Mars? What do we plan to do? Trade with Mars? Bananas, they produce potatoes and we trade bananas for potatoes. Is that why we're going to have a colony on Mars? Will those people ever come back? Why would we do a one-way trip to Mars and those people just stay there? I mean, it's like paying for someone else to have fun, assuming, they have fun out there. Okay? Or are we going out there just to see the world, to have a little vacation and say, oh, I've been to Mars a week and now I came back? Is that what Mars is for? I mean, are we going to evacuate the Earth? Maybe all the prisons and put them out there and say, hey, all the prisoners go to Mars now? Penal colony, like the British did with Australia and Guyanas and so on. Yeah, the question is why? Why would we go to Mars? And so I don't know even if Mars is ever going to happen, but if it does happen, maybe the first trip will be with robots, some exploration of some kind, just to see if we can get there. And meanwhile, they're going to prepare some astronauts. Whether we're ever going to make it, I don't know. I think that maybe the world, humans will become extinct very soon, and I'm not sure if they're going to beat that deadline. Okay, that's my take on that. Have other civilizations sent a bottle, a message in a bottle. Like when you get stuck on an island, you send a message in a bottle. Arrives in California and they know to pick you up over there in the Pacific somewhere. He's suggesting that maybe they left something in the genome, maybe by looking casually through some thousands or gazillions of DNAs or chromosomes or whatever, we find some code. Say, oh, hold it, this wasn't Mother Nature, this had to be from some alien. So that's one of the messages in the bottle he suggests we could look for, spend our time looking for. And the one that struck me the most is really the last one. Civilizations that made it to the future. He just mentions that in passing, like saying, a lot of civilizations may die, like Carl Sagan suggested. In fact, I mentioned that some time back. And the question is, how many of those surpass their infighting, killing each other, becoming extinct? How many surpass that moment, are able to get beyond that point, and they all become friends, on their planet? The blacks with the whites and the browns and the yellow, all these races come together, all the religions come together, the Muslim kisses the Christian and so on, they all finally leave all their differences aside and they work towards the future and they create this great civilization that allows them to expand further, maybe to other star systems and maybe even throughout the galaxy. And so that is really the one that struck me. Here you have his take on that, a second take that he gives. He says, looking for ETs is like looking into our own future. Okay? if there are many civilizations that have made it through their mini crisis, mini crisis, okay, and like saying that's petty stuff, yeah, infighting, and have gone on to a glorious future, well then, we see in the sky a trajectory of the future of humanity. Searching for them out there is searching for ourselves. Okay? You see where he's going with this. So, all these people, mathematicians like Carl Sagan and good old Davies here, we'll include Hawking in there as well. All these people thought in the same way. And they're all thinking, you know, if humanity doesn't destroy itself, that's their key issue. In other words, the only way man can become extinct in the minds of these people is if we kill ourselves. We commit suicide by killing each other, infighting. More or less like the T-Rex did at the end, you know, they killed each other when food ran out. So they had to kill each other. They had to do cannibalism because there was nothing left as food. Are we going to do something similar here? We're going to eat each other? Are we going to shake hands, kiss each other, work together in cooperation, you know, and build the future? Is that how humanity is going to progress in the future? Well, one of the issues that you would think these people analyze is, you know, what are the possibilities of life existing out there to begin with before you start searching for it? Is there any possibility of there being life out there? And yeah, they did analyze that, and he analyzes that in quite a bit of detail. It's known as the Drake Equation. Okay, here's the Drake Equation for those of you who are not familiar with it. Okay, and it goes something like this. He says, what are the number of technologically advanced civilizations in the Milky Way galaxy? This is just the Milky Way, okay, just one galaxy here. And so they go into all these different groups. They study out there and they try to figure out what's out there and what they can see, what they can measure, okay? And the first factor there is the rate of formation of stars in the galaxy. Well, the University of Calgary has come up with a number, okay? So there are roughly 150 billion stars born per year in the entire universe. 150 billion per year. This corresponds to about 400 million stars born per day. So that's a lot of stars. How many of those belong to our galaxy? Well, if I heard Davies correctly, I think he said 7. Okay, 7 stars per year on the average. Okay, that's good. So we have a number. Second point is fraction of those stars with planetary systems. How many of those have planets? And it says at least 1 in 6 stars has an Earth-sized planet according to NASA. Okay, so the NASA folks, they said there's at least 1 in 6 stars. About 16% of them that they've seen out there, they say has at least one Earth-sized planet. Okay, we have a second number. The next one is the number of planets per solar system with an environment suitable for life. And they determine this by looking at whether it's got oxygen, whether it's got some kind of atmosphere, whether it's got water, those kind of things. And Berkeley, and one study, it came in 2013, I think it's the only study it really says the fraction of stars with Earth-like planets is about 22%, plus or minus 8%. Okay, so they have wide spread there. Okay, but you can see I stopped at the green line. Anything on the left side of the green line tells you something about that we can determine objectively. Okay, more or less objectively, we can look out there and find out, okay, this planet has this planet has that, this star has this, and we can more or less draw some conclusions from the measurements that we make. Those are objective, you could say, okay, or more or less objective. What happens on the right-hand side of that green line, which I've outlined in green, is you got these other 4 factors in the Drake equation, and these are all speculative. Yeah, you see the fraction of suitable planets on which life actually appears. Okay, we have no idea. Fraction of life-bearing planets on which intelligent life emerges. And I guess intelligent life, they refer to human-like intelligence at least, right? So anything that is not us does not count. That means there is a small fraction, okay, of the planets where life appears, okay? Then we have 2 more factors, and those are the ones that also interest me. fractional civilizations that develop a technology that releases detectable signs of their existence into space, and the length of time such civilizations release detectable signals into space. Okay? Why did I circle them or draw them in red? Well, I have my own equation. I'll share it with you today. Okay? This is my equation. Okay? Here it is, for those who want to see it. I multiply all this times 0. Okay? All those factors times 0 for civilizations that we can contact, okay? Or that can contact us. That's my equation. So I'm not concerned about how many civilizations out there, technologically advanced civilizations are out there. I'm concerned about how many of those we can contact or can contact us, and whether it's worth even doing anything. I'm saying it's 0. Okay? Say, Bill, you're a little pessimistic. Today I drank too much beer, so I guess I'm a little pessimistic. Let me tell you why I'm not pessimistic. It's called realistic. Let's be realistic. Okay, and here's the realism that I propose for that 0. Okay, here it is. Okay, this is my Bill Gaede equation, why there is no possibility of ever contacting or receiving messages from another world. Okay, that's what my equation has to do with. The curve of life of an intelligent species such as man is geologically short. Very small window of opportunity. Okay, our doomsday clock, we talked about the doomsday clock the other day, okay, shows that technology necessary to communicate with other worlds develops in the last minute. We've only had, and I'll be very generous, we've had 200 years of communicating technology. I mean, I'm not talking about smoke signals from the Indians or maybe a drum. No, I'm talking about, mastering electricity, the telegraph, that kind of thing. And I'm including those within this, okay? So I'll give it 200 years to be on the safe side. That should cover all the technology that we have invented regarding transmission and reception, okay? Radios, TVs, they're only 100 years old, okay? Okay, what's the problem with that? Well, we're close to doom. And so that gives us an idea that we only have 100 to 200 years, that's all that humanity has to transmit and receive. That's a very small geological window right there. And of course, if, like I say, we're about to become extinct very, very soon, that's it. That's all the time. That's the entire span. That's the entire range. Okay? And considering, when you talk about the sun being there 5 billion years, 100 years is not too much. Not even 1/10 of a percent. We're talking about a very, very small window there. It takes thousands of years, for most stars at least, right, for light to reach planets inhabited with human-level intelligence. And, we're staggered also. The next point there, planets with human intelligence, that's what they call it at the CIA, human, are staggered in time. In other words, here we are. We had our 200 years of glory, right? Our golden age, where we have all this technology and internet and all that stuff. It's great stuff. We can also see all the history in the past, say, oh, look what happened to Napoleon and this guy. They don't know what happened to us, but we know what happened to them. So there's a lot of advantage of this day and age, right? In that sense, at least, right? But assuming we're only going to live 200 years with this technology of transmitting and receiving, imagine another planet. Yeah, they might have life. They might have even developed intelligent life, maybe intelligent life similar to ours, evolved there. Well, maybe they're 100 years behind us. And so when we go out, they come in, they say, oh, let's look for life out there. Let's see if we can find, oh, there's a planet, Earth. It's got water, it's got oxygen. Maybe there's life on that planet. Let's send a message, see if we receive a message in a bottle. And it turns out we're all dead here, so we can't send anything. Then there's the issue of signals. Under the rope model, you send them through the electromagnetic ropes. But what happens with any rope? Well, from the point where it's on the wall outwards, the links become longer. It's known as the redshift. So all this stuff about, you know, the universe flying apart, well, maybe there's a different take on that. Maybe that redshift is evidence, right, of something else, of just light, the rope, becoming longer and longer, the links becoming longer and longer and longer. What does that mean? It means lower and lower frequency. And if we put that into a signal that is sent out, by the time it reaches Alpha Centauri, which is only 4 light years away, let alone one that is thousands and thousands or millions of light years away, I don't think much is going to reach them. Maybe a faint light. I mean, how much light do we receive from between the objects we can see in the sky? You know, that black stuff we call space? There's stars there. And there are planets there. And we don't receive the light from those because they're just too far away. And between them and us, light, what happens to the light that they emit? Well, it eventually dwindles into longer links. And so it fizzles away. And so if we send light out, send messages out, or try to receive messages, we're going to encounter also the dilution of the signal. So that in a nutshell is what I suggest, that we're wasting our time because it turns out that people like Paul Davies, they ask for donations to help SETI look for intelligence out there. And I think these people are dreamers. They watch too many Star Trek movies, or maybe Twilight Zone, Outer Limits episodes. They're kidding themselves. Not only we will not find anything out there because the lifespan of intelligence is too short, and even shorter is the lifespan of intelligence, which developed technology to transmit and receive. It's not even a drop in the ocean. And so that's one issue. The other one is, again, the signal gets diluted. They're too far away, and then they're staggered in time. That, in a nutshell, is my 5 cents worth. Okay, let's get to the questions of today. Questions and comments that people put out there. Here's one. Says, are you still doing science or are you doing religion now? I love that one. Well, whenever I analyze mathematical physics, I have no choice but to do religion. That is religion. You know, and when you look at history also, when you look at traditional religions, and they thought they did science and you analyze them, well, you got to do a little religion as well. I mean, all these people talk about beliefs and opinions, right? Now, there's another possibility here. I don't know really what he was referring to, but maybe he was saying that some of the subject matter that I bring up is related to religion. Maybe. See, if you look at issues like the fact that physics requires an object and that physics is the science of existence, a lot of people believe or have this in the back of their mind that existence has something to do with philosophy. And so when you do philosophy, people also relegate that like, oh, you're doing religion, you're doing stuff that is not science. And no, existence belongs squarely within physics. Physics is the science of existence. Physics not only tries to figure out what exists out there, make assumptions about what exists, and, you know, what happened, which is, you know, putting that existence in motion. And so that is science. That is subject matter of science, specifically of physics. Okay, so we have to understand first what religion is, opinion, belief, that's religion, and science is explanation. And I try to do explanations here. But in order to do explanations, you have to make some assumptions, and that has to do with existence. And again, we do not prove existence like these people try to do by putting their telescopes out there and saying, I'm going to prove that the aliens exist. No, that's not science, okay? If you want to prove that the aliens exist, all you have to do is make an assumption. Say, let us assume the aliens exist. And now you can explain whatever you want with that assumption. That's the way it works in science. Okay, another issue here. Is there a list of hypothetical extinctions of animals and plants with the duration of their existence in years? Number of Earth evolution, I guess revolution around the sun. That's what he meant. No, we don't have a detailed listing of animals that exist. Some animals, we have only one bone. They found it inside the rock. They assembled it. Maybe we only have one example. You know, one item to analyze. And with that, they create the name of a species, and they go, you know, from that point on, they try to fit it within the family tree of dinosaurs, of synapsids, of archosaurs, or whatever. And this is what we do have, okay, if this helps any. This is essentially the extinctions that have occurred over time, and what it's all about is numbers. You know, you don't have a qualitative, breakdown of this. All you have is just numbers. And that's why they call them background and mass extinctions, because they're just looking at numbers. They can't really tell you exactly all the species that existed, that were living in those days, that were around. They can't tell you any of that. Okay? So no, we don't have a listing of all the species. Not even by a long shot, okay? So we're not even close. All we can do is, that's why I'm saying, you know, science is not about collecting samples. You know, paleontologist is not a guy who goes out there to the field, breaks a little bit of rock, pulls out a bone, dusts it off, you know, gives it a fancy name, puts it in the museum, and then starts collecting entrance fees. Now that's a stamp collector. That's not a paleontologist. Paleontologist is a guy who tells you how species died. That's the job of paleontologist. After he told us how they died, he gives us a rational explanation. We're done with paleontology. There is no more paleontology after that. All we have after that is stamp collecting. Okay. Okay. Another comment. I think the same fellow. Okay, and he says the following. He says, about the population curve, there is a fourth possibility, reduction of the population by world war. Yeah, I think the day we get to World War III, you know, that's it for the world. And World War, I put it in the context of resources. The only reason for World War is resource, primarily food, anything related to food. And that's the only time that might arise. But if the global economy collapses, as I say will happen, World War is probably going to be a part of that process. Okay, so we're going to reduce the population if we throw the bombs at each other, right? Or like Einstein said, I don't know how the Third World War will be fought, but the fourth one will be fought with sticks and stones. Okay, so yeah, the day that we throw the bombs, I think that's it for sure. But we're probably going to die more than likely because of food. People are going to starve to death, not because the bombs killed them. Aside from the fact that the first thing that the military will do is throw bombs at the other guy's bombs. So bombs will be killing bombs and probably spare a lot of the cities because of that. And so a lot of people will survive, but then they'll die of starvation because there will be no food. Okay, next issue. It's not going to cut it as an explanation that these threads are invisible and intangible. But they are objects because irrational science definition, an object is that which has shape. Well, yeah, because you're confusing two things. You're confusing invisibility and intangibility with shape, and one has nothing to do with the other. You know, you can't see, you can't see the air, and the air has shape in there. Those atoms have shape, hopefully. And I know because I can touch them. At least I can touch them. I can't see them. You know, and so, yeah, you're confusing the issues. Tangibility and invisibility or visibility have nothing to do with the word shape. Okay? Those are verbs, by the way. and shape is not a verb. But where does invisible, intangible threads have shape? Well, here, let me give you an example. Okay. So I think if you illustrate it, it falls in easier. Here's God, good old God, and he can see the tri-bar, maybe written on a piece of paper or something. Can he touch the tri-bar? No, he can't. So tri-bar is untouchable. He can see it only if it's on some kind of platform. I don't think there's a tri-bar floating out there in space, right? But now, here we have good old God, okay? And he can imagine, he can visualize a tri-bar, while he's got all these pink mammoths flying around himself, right? He can imagine, he can visualize. So shape is something you visualize. You can visualize it in your brain. That does not mean that you're going to use your eyes. You're going to use your mind, okay? Your brain, in other words, okay? Because if I say mind, they'll say, oh, that's a concept. Yeah, it's a concept. Thought is a concept. The fact that you can visualize, imagine, right? That shows you shape. You don't need to see, and you do not need to touch. Okay, seeing is outside. Okay, not inside. Yeah, the signal goes in there. But shape, in fact, doesn't need an observer whatsoever. If God, assuming God disappeared afterwards, made a cube in the middle of space, that's all he made, just a cube. That's it. And that's all we have there, a cube floating in space. That cube has shape. We still don't have touch or see. No touch or see because you need something else. God needs to be there to touch or see it in the best of cases. Okay? But if cube is all that there was in space, it has shape but no touch see. So yeah, touch see is a different criterion or set of criteria than shape. Okay? They should not be confused. Okay, another comment here. We can see atoms with atomic force microscopy. We can see atoms now. Don't shout. It's how much of an atom we see. That's the issue. I mean, here he sent me to a Google site. I mean, he just Googled it and he said, look, we can see atoms. Here they are. And this is what you find in what he posted, okay? And there you see tons of atoms. They're all in arrays, okay? But I don't see any individual atom. All I see is a bunch of bubbles there or little circles in the best of cases, okay? And the question is, does this qualifying as seeing an atom? What are we seeing? Okay, is this what we're seeing? Is this what you're seeing in there? What I showed the other day? Is that what those circles are? I mean, are we talking about a little bead that's going around in circles and that is what creates that sphere that we see there? So are those spheres just circling of beads? What is that circle? Is that what we call an orbital? What is an orbital? What is an orbital made of? Okay, so what are we staring at? I mean, are we staring at a balloon, at a shell? Or are we staring at a trajectory of our little bead around a so-called orbital, what is an orbital? Just a bunch of orbits, just a region, according to Schrodinger's equation, a region where we can find the electron bead. I mean, I didn't see any bead going in there either, did you? All I saw was this balloon or this sphere in there, right? Okay, let's look at this in a little more detail. Okay, here are some atoms that put out by IBM that they filmed. Okay, these are atoms. They moved one atom at a time, they claim. Okay, and so the question is, all I see is a bead. I can't see inside that atom to find out what that atom is, how it's made. I don't see the architecture of the atom in there. Okay? All I see is just them moving atoms. And they say, oh, we've taken pictures and we've filmed atoms. Yeah, we filmed them, but we can't see inside the atom. That's the point. The point is, I need to see the structure of the atom. Okay, again, is the atom that spinning bead, that goes around? Is that what an atom looks like, with a proton in the center and a little bead going around? What is this orbital thing? That's the issue we want to answer, and that's only one of the issues. Here's one of the pictures from that group of pictures that he's Googled. Okay, and you can see it here. This is graphene, one of the pictures, and you see the array there. Okay, you see all these atoms, and they had to draw the connections. What did they draw? Well, they draw these sticks, these lines. Well, what are those sticks? I mean, I don't find them in the standard model. You don't see sticks there. It's more or less like that glue-on thing where you see the glue-on bed spring holding the quarks together so that the quarks don't fly apart. Well, I don't see bed springs in a standard model. Likewise, I don't see sticks or bed springs, for that matter, in this array here. So what are those sticks? That's what I want you to tell me. Aside from the orbital, right? We haven't forgotten about the orbital. We need the orbital and we need the sticks, okay? So we need both of those. When you identify them, then I'll agree that we have photographed an atom, okay? Okay, if you can't do it, well, you haven't photographed an atom. You have to make some assumptions, and hopefully the assumptions are rational. We don't have a bead going around without any connection to the proton. I mean, is the proton, swinging the electron around? Is that the way? Is this what the proton is doing? So I want you to tell me what this string is in the case of the atom. If my hand is the proton and it's swinging, the electron around, what is the string? What holds the electron faithful to the proton? That's what I need for you to tell me. So orbital, whatever holds the bead to the proton, and then the sticks, right? Sticks and stones. You got to identify those. Here's another shot of that graphene. Other people from that same list, by the way. Okay, and here you can see them. They put all these sticks between the carbon atoms, and so I'm saying, well, what are those sticks? Please identify those sticks. I mean, people put them there, but what does that mean? Does it mean we know what they are? So you need to identify the sticks, okay? And let me show you here. This is what a carbon atom looks like, more or less according to chemistry, at least. Okay, this is the way they illustrate it. Okay, and you can see that the carbon atom is a little more complicated than just a circle. Now it's got the S1, the globe in the center, the orange one there, and the S2 orbital, the one around it, and then the two p orbitals. That's what the carbon atom looks like. Okay, and so you can see the little beads there, and they're flying around. Why don't they leave the orbital? What keeps them bound to the orbit? Why doesn't that little bead just fly out? That's what you got to answer. And if you don't have a logical answer for that, then you don't have an atom. It doesn't matter if you say, well, we photographed atoms, but you can't tell me what the internal structure of an atom looks like. So I need for you to identify those little beads. And here, let me give you an analogy, okay? Just so you can see where I'm going with all this. Okay, here you have a fly, okay? And you see the fly going around in different directions, but you look at it for a while, you stare at it, and you find out that it's always in a region. I mean, why doesn't it fly out of the picture, out of your field of view? Why is it stuck in that black invisible region? Why is it flying around always in circles, more or less? And right, what happens is you have to make the invisible perimeter visible. So we make it visible and we find out, the fly is stuck in a balloon. So he cannot leave the balloon because, there's a physical impediment for the fly to fly out. The fly is only putting its legs or its feet or whatever against the rubber, and it can't get out. So now we can understand why the fly is going around. And that's what we need for you to do, with the electron. If the electron is a bead that floats around a balloon, okay, called an orbital, we need for you to identify that orbital and tell us why that bead doesn't fly out of the orbital. What is the orbital made of? Is it made of rubber? I mean, you tell me. So no, the fact that we have taken pictures of an atom from, from 5 gazillion light years away does not tell us what the structure is of that atom. That's what we need to figure out. And if we can't figure it, and if we can't take a picture of what's inside an atom, we have no other choice but to infer. We have to make an assumption and say, well, let us assume this and this, and with that assumption, explain the functioning of an atom. Okay, that's the way it works in science. Okay, here's the rope version of that same carbon atom. Okay, here it is. We have nested spheres, and we have the p orbitals, which are not orbitals, they're balloons. They are membranes, and it's essentially, in the case of carbon, several hydrogen atoms merged together. Okay, they blended. Their electron shells have blended into each other, and they form this element called carbon. And that is done, as far as I'm concerned, through pressure inside the sun. I do agree with that. Okay, that's my assumption as well. That's the one I use. So here you have the rope version of the carbon atom. Okay, and let's look at graphene now. This is their version of graphene. And you can see again, it's the sticks and stones and threads. They have James Bonds there. What is that bond? I mean, what is it made out of? Is it some elastic band that's going across from one place to another? You got to identify this stuff. These guys put it in there like if you knew what they're talking about. Okay, and so now you got to identify the sticks, the threads, the bonds. And what is an orbital? Is it many orbits? You got to identify each one of these, otherwise you're not doing science. You don't have an assumption, you don't have a hypothesis to begin your presentation. What do we propose instead? Well, here's our graphene. Okay, 6 carbon atoms there. Okay, more or less merged together. They have ropes connecting to other atoms as well. Okay, and the ropes, I didn't draw all the ropes. There's gazillions of them in just those 6 atoms. Remember, each one is made of essentially 6 hydrogen atoms, each one of which has a rope connected to all other atoms. So you can see how monstrous this thing is. It's very tightly bound. That's why the molecule does not break apart so easily. I mean, it has a tendency to stick together as a solid. Okay, so there you have a difference between what mathematical physics proposes. People like my good friend Paul Davies, he does it with sticks and stones. He never identifies what he's using there. Here we have a physical version of the atom and of graphene, in this case a molecule, right? So ours is rational in the sense that you can visualize it, and people might say, well, Bill, I don't believe in it. That's religion. That's when you want to talk about belief and opinion, whether I'm right or wrong, whether I'm true or false, whether I'm yes or no. Now you're talking about religion, and that does not concern science. With that, I'll see you on Sunday.